Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0115-1C, indicates an issue with the Engine Coolant Temperature, ECT, Sensor 1, which has output voltage readings that are out of the specified operational range. The ECT Sensor 1 plays a critical role in monitoring the engine's coolant temperature, allowing the Engine Control Module, ECM, or Powertrain Control Module, PCM, to optimize engine performance and emissions control. This sensor is generally located near the thermostat housing, which is connected to the engine cooling system. By determining the coolant temperature, the PCM can make informed decisions regarding fuel mixture, timing adjustments, and emissions control. When this sensor reports an out-of-range voltage, the PCM identifies it as an abnormal condition and stores the DTC to alert technicians for further investigation of possible faults. Addressing this code promptly is crucial for maintaining optimal engine performance and preventing overheating or other engine-related issues. The main affected component in this issue is the Engine Coolant Temperature, ECT Sensor 1, which monitors the coolant's temperature as it circulates through the engine. The sensor sends this information to the Powertrain Control Module, PCM, which uses the data to make critical adjustments to engine functions. The PCM is responsible for optimizing engine performance, improving fuel efficiency, and controlling emissions based on the temperature information provided by the ECT sensor. This sensor is typically located near the thermostat housing, which facilitates efficient coolant flow and regulates engine temperature. A malfunction in this sensor can lead to incorrect readings, which can compromise engine performance, causing issues such as poor fuel economy or increased emissions. Surveillance systems, such as the HDS, Honda Diagnostic System, are used to read the sensor outputs and to diagnose the specific faults associated with these components. The possible causes for the DTC P0115-1C include several factors. First, the most common issue could be a faulty Engine Coolant Temperature, ECT, Sensor 1, which might be unable to provide accurate readings due to internal failures. Next, there may be wiring issues, such as shorts or open circuits, that could lead to the sensor not receiving or sending the expected reference voltage. A short might keep the sensor output flat, while an open circuit could prevent it from reporting at all. Lastly, a failure in the Powertrain Control Module, PCM, itself could also lead to false readings and cause the code to be triggered. Each of these components must be systematically inspected and tested to determine where the exact fault lies. Symptoms associated with the DTC P0115-1C may vary, but they often include poor engine performance and increased fuel consumption. If the ECT Sensor 1 is providing incorrect data to the PCM, the vehicle may run richer or leaner than optimal, affecting performance. Additionally, the incorrect coolant temperature readings can result in the engine not achieving an efficient operating temperature, leading to further performance issues over time. Emissions issues are also possible. If the engine is running improperly due to incorrect temperature readings, it may fail to meet regulatory standards, potentially triggering check engine warning lights and failing emissions testing. Drivers must stay alerted to these symptoms to address potential problems before they escalate. The first step in troubleshooting the DTC P0115-1C is to turn the vehicle to the on mode without starting the engine. This action powers the onboard electronic systems, including the diagnostic tools used for testing. Next, utilizing the Honda Diagnostic System, HDS, one should check the ECT Sensor 1 voltage value. Ideally, the voltage should be greater than 0.16 volts. If the reading is less than this threshold, it indicates that a failure exists and further investigation is required. If the voltage reading is normal and above 0.16 volts, Attention should then turn to other potential related components, confirming that the ECT sensor outputs the correct voltage. Carefully monitoring data through the HDS at this stage is crucial for diagnosing the fault accurately. For the second troubleshooting step, you need to disconnect the ECT Sensor 1 connector, which typically has 2 pins, to isolate the component for testing. Following the disconnection, ensure that the vehicle is still in the on mode and recheck the HDS readings for ECT Sensor 1 voltage. If the voltage reading is normal over 0.16 volts, it suggests that the ECT sensor itself is faulty. However, if the reading continues to remain abnormal, the next likely culprit could be other related components within the circuit. These steps are critical in isolating whether the problem lies within the ECT sensor or the circuitry involved, ensuring that the diagnostic process is thorough and effective. In the third troubleshooting step, inspect the wiring associated with the ECT Sensor 1. Before examining the wire connections, it is important to make sure that the PCM connector is also disconnected for safety. Use the HDS to check for continuity and to see if the circuit has any shorts or opens. Ideally, with all connections properly inspected, the wiring should reveal a resistance of more than 1 megaohm when using the HDS in IG mode. If this measurement comes back lower, it indicates that a wiring issue exists, which could be causing the erroneous readings from the ECT sensor. This test helps ensure that the wiring integrity is maintained, which is essential for proper functionality of the ECT sensor and subsequently the entire cooling system's performance. The fourth step in the troubleshooting process involves inspecting the powertrain control module, PCM, itself. After confirming that both the ECT Sensor 1 and wiring are functioning correctly, it's time to evaluate the PCM as a potential source of the issue. The PCM oversees multiple vehicle operations, including managing the input from various sensors, like the ECT. If earlier tests have confirmed that both the ECT sensor and related wiring are functioning as they should, the investigation shifts focus to the PCM. Any faults identified here could lead to miscommunication within the vehicle system, resulting in DTC P0115-1C being triggered. Reassuring that the PCM operates under the correct conditions is paramount for vehicle reliability. After completing all troubleshooting steps, it's essential to verify any repairs made. Start by clearing the DTC from the Powertrain Control Module, PCM, which resets the system and allows for a fresh diagnosis. Once cleared, conduct a test drive to ensure that the DTC does not reappear. During the test, closely monitor the ECT sensor performance through the HDS to confirm that it operates within the specified range. It's vital to ensure prior repairs were successful, especially if components were replaced. So validate that they are performing to manufacturer specifications. Successful verification will result in the absence of DTCs, communicating that the vehicle's cooling system is functioning correctly. Implementing preventive maintenance is critical to avoid future issues with the Engine Coolant Temperature ECT sensor and ensure the long-term performance of your vehicle. Regular checks of the ECT sensor should be part of routine maintenance, especially during coolant changes or engine inspections. This will help identify potential faults before they lead to significant problems. Additionally, consider conducting routine vehicle diagnostics using the Honda Diagnostic System, HDS, to monitor various sensor behaviors and the overall health of the engine system. Preventive measures like these not only maintain operational efficiency, but also contribute to better fuel economy and lower emissions, ensuring a well-performing Honda CR-V. In conclusion, Addressing DTC P0115-1C effectively requires a structured approach to troubleshooting, focusing initially on the engine coolant temperature, ECT Sensor 1. Identifying whether the sensor is functioning correctly is crucial, as it plays a significant role in overall engine performance. Additionally, confirming the integrity of the associated wiring prevents miscommunication between the sensor and the powertrain control module, PCM. If needed, the PCM itself should be inspected, particularly if issues persist after addressing the sensor and wiring. Implementing regular preventive maintenance practices will help ensure ongoing operational reliability, contributing to better vehicle performance and longevity. By following these steps, technicians can systematically resolve the issue while enhancing the vehicle's efficiency and reliability. Please like and subscribe to the channel. See you next time.